The virus that came in that we're talking about is a virus that's spread by mosquitoes. The CDC has certain projections, but they can't really make projections. For example, they gave a very good recording of what's actually happened so far. They looked at the United States as of March 9th, 2016. Travel-associated Zika viruses, disease case reported 193. That is in the continental U.S. What does that mean? That means that everything you see here in blue is actually people that traveled overseas, came back to the continental U.S., and they got the virus. But notice that locally acquired cases reported, when we look at the numbers, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Now, in U.S. territories, which include American Samoa, Puerto Rico, U.S. Virgin Islands, there's only one travel-related infection. In other words, somebody went overseas, came back to Puerto Rico, boom, there's one. Now, all the other ones they got while they were in Puerto Rico, from the mosquitoes from Puerto Rico. That's totally different. I'm going to just talk really quick about the continental U.S. because it's not the same. There's 193 cases reported as of March 9th, 2016. That's 193. This graph is from January 1st, 2015 to March 9th, 2016. That is not to say that the virus didn't start from beforehand, because it was first diagnosed back in the 40-somethings. Locally or kind of close by, it was like 2006 maybe, 2009. So this is just starting January 1st, it started taking numbers, and it jumped from, let's say, 1 to 193. To use that graph, we have to use the following equation. How many infections do we have is equal to the initial amount, which in this case is 1. There was one case reported, let's say, January 1st, 2015. So we're in March now, so it'd be 15 months basically. So we're going to try to track per month. This we multiply by 1 plus the rate over 15 months. I'm going to call it T, or time. We know a few things. We know that right now we have 193 infections. We know that initially we had to start with 1. 1 plus we don't know R, and it's been 15 months. From this equation, we can solve for what the rate is. And now, this is just a guesstimate because projections are always just, okay, this is kind of the trend, but we have to make sure. So let's do the math first. To be able to solve for this, really the only way is I'm going to take the ln of both sides, so natural logarithm. What that means is I'm going to take the natural logarithm of this side. The 1 just stays 1, the natural logarithm of 1 plus r raised to the 15th. Now, because we're using natural logarithms to try to solve for r, we can bring the 15 down using the rules of natural logarithms. So this side is 15 times 1 plus r. That's nice, because now I can take this 15 and divide it by both sides. So I have, on this side, I have the ln, or natural logarithm, of 193 divided by 15. And that's equal to the natural logarithm of 1 plus r. But I'm not looking for the natural logarithm of 1 plus r, I'm looking for r. What do? Well, luckily I'm like super smart in math. So what I do is, I take the e of both sides. What this does is it raises the natural logarithm, 193 over 15, is equal to, that's e raised to ln of 193 over 15, and I'm going to raise this side to ln of 1 plus r. Again, using logarithms. If I plug this into my calculator, This is e to the 5 point something, and then that e raised to the 5 point something comes out to 1. Zoom this so you guys can see it better. 1 minus, 1.43 is equal to, that's doing the math for this. In my calculator, I plug it in, and I get 1.43. This side becomes, this cancels out with this, so I'm left with 1 plus r. Math is cool, at least for us nerds. So what I do is I subtract 1 from this side, and I'm left with the rate is equal to 1.43. I'm sorry. Subtract 1 from both sides, so the rate comes out to be 0.43. Now I can plug it in and find projections of where the next one's going to go. I'm going to show you a picture. Because our rate is 0.43, I can continue and say, okay, I want to know 15 months. Nah, I don't like 15 months. That's January, February, March. Where it's going to be in March, April, May, June at 18 months. It's been 15 months. I add 3, it's 18 months. At 18 months, how do I do that? Well, I start with 1, infection. 1 plus 0.43 raised to 18 months. Raised to 18 months. Raised to 18 months. Raised to 18. Doing that, I get a certain number. 1 plus 1.43 raised to the 18. That's A at 18 months. I can do the same thing for, that's halfway through, that's a year and a half. Then I do 24 months. Actually, let's just do, add 3 to this one. That would be 21. 21 months. And then A at 24 months. Now this is conditional. I mention that because conditional means that if this graph doesn't work and at 24 months in 2 years the number that comes out does not come out to be true, then this projection is not true. But we can verify it. The CDC will give us a number. Let's look at what the actual graph looks like. I made a comparison here. Back to this, Zika Virus disease case reported 193. From that U.S. territories I didn't cover because basically there are none in the continental U.S. Locally acquired vector-borne cases reported 0. That means that locally they were not acquired at all. They're just people that travel from different countries. We looked at 00000. There was no infections currently. That's of January 2015. In the territories, there was a huge jump in Puerto Rico, but that's separate from what we know. Now what we try to do is we try to graph this puppy. If we try to graph it, what that means is I'm going to put in the first month I had 1 infection. In the second month, if I look closely, I have 3 infections. In the 6th month, I have 8 infections. In the 9th month, I have 23 infections. In the 12th month, 67 infections. In the 15th month, that's March of this year, I have 192. So far, that graph looks correct. But notice what happens. In the 18th month, we're supposed to have 551, roughly 550. Now, in a few months, 3 months from now, if that number does not show up, if 551 does not show up, what does that mean? That means that, sorry, it doesn't work that way. This model does not work. So the exponential equation that we used is wrong. If in the 24th month, we're not even close to 1578, which is here in this graph, over the course of the months, if we're not at 1578, then the formality is wrong. And then after 2 years, 4,500. This is just a projection, and that's what you need to understand. Projection is just projection. It could bottom out at 192 and not have another infection for the next 6 months to 3 years. They try to do that projections oftentimes to scare people, basically. If we had 4,518 cases by the 24th month, which is 2 years, we would have a serious problem. But we have gauges, we have 192 at 15 months. Now, if we reach 551 at 18 months, okay, we're concerned, but even that number is extremely small compared to our population size. It looks exponential. Let's see what happens in the 18th month. If we have 550 or 551, then we can be concerned with it. I'm hoping this helps you. I went ahead and send you the graph, PDF, and the report from the CDC. And hopefully this will help you for a report.